let's have a look at the last question in this paper, question 5. So this is a variable acceleration topic. Yeah, so vectors. At time t seconds, a particle p has velocity v meter per second, where v equal to 3t to the power half I minus 2tj, and then t is more than 0. We want to find the acceleration of p at time t seconds, where t is more than 0, okay? So we have velocity. If we want to find the acceleration, we just have to do differentiation. So we have v is equal to, if we write as the column vector, that would be 3t to the power 1/2 and then negative 2t. So if we want to differentiate that, so the acceleration should be bring down the power and then minus 1 the power. And then negative 2t differentiate is just negative 2. So then that's our acceleration vector, which is part A. And then for part B, find the value of t at the instant when p is moving in the direction of I minus j. So every time when they're talking about the direction of motion, we always use the velocity vector. So it just means the velocity vector is parallel to I minus j. So velocity vector, we have 3t to the power 1/2 and negative 2j, and negative 2tj, and then it's parallel to I minus j, which is 1, negative 1. So if two vectors are parallel to each other, then the scale factor between each component has to be the same. So the scale factor between component I has to be the same as the scale factor between the component j. So then to set up the equation, you just have to do 3t to the power 1/2 over 1, and then let it equal to the scale factor between the j component. So negative 2t divided by negative 1. So all you have to do, just do I divided by I equal to j divided by j. Because when you do I divided by I, that will give you the scale factor between the I component. And then when you do j divided by j, then you'll get the scale factor between the j component. Since those two vectors are parallel to each other, the scale factor has to be the same. That's why you can just let them equal and solve it. So in this case, you'll have 3t to the power 1/2 is equal to 2t, and then 2t minus 3t to the power 1/2 equal to 0. So then if you factorize them out, you can factorize out, let's say, t to the power 1/2. Then you will have 2t to the power 1/2 minus 3 equal to 0. So then either t to the power 1/2 equal to 0, or t to the power 1/2 equal to 3 over 2. Then we have t is equal to 0, or t is equal to 9 over 4 if you square them. And then clearly t cannot be equal to 0 because it says t more than 0. Then ignore that. So t is equal to 9 over 4, which is the final answer for B. Okay, let's have a look at part C. At time t seconds, where t is more than 0, the position vector of p relative to a fixed origin O is r meters. And then when t equal to 1, r is equal to negative j. We want to find an expression for r in terms of t. So we have the velocity vector, which is 3t to the power 1/2, and then minus 2t. And if you're looking for the displacement, you just have to integrate it, to get the position vector. So when you do the integration, 3t to the power 1/2, so you plus 1 the power, and you divide by the power. And then for negative 2t, you just plus 1 the power, divide by the power, and then plus c. So simplify a bit. So you have, 3 divided by 3 over 2, you can put in the calculator, that would be 2t to the power 3 over 2. And then negative 2 over 2, just negative 1, so negative t squared plus c. And now substitute in the condition. It says t equal to 1, r is equal to negative j. So if we substitute in, negative j means 0, negative 1. So 0, negative 1 is equal to 1 apart anything is 1, 2 times 1 is just 2. And then 1 apart 2 is just 1, and the negative of that is just negative 1 plus c. So c should just be equal to 0 minus 2 is negative 2, negative 1 minus negative 1 is equal to 0. So therefore, the displacement vector r is equal to 2t to the power 3 over 2 negative t squared plus c, which is negative 2, 0. So put them together. You can write as 2t to the power 3 over 2 minus 2, and then negative t squared. And then for part D, find the exact distance of P from O at the instant when P is moving with speed 10 meter per second. So speed is the magnitude of the velocity. So we have the velocity vector. So you just have to find the magnitude and then that's equal to 10. So the magnitude is very simple. All you have to do is just square root of the I component. So 3t to the power half square, and then plus the square of the j component, negative 2t. And then that's equal to 10. So square them for both sides. Then we have, so 9t. So if you square that, it's just 9, and t to the power half square would be just t. And then plus negative 2 square is 4, and then t square just t square. And if you square the whole thing for both sides, it will cancel out the square root. And then 10 squared is 100. So we have 90 plus 40 squared equal to 100. And then move everything to one side and then put into the calculator. So 4, 9, and the negative 100. So t is either equal to 4 or t is equal to negative 25 over 4. Again, t cannot be negative, so not divided for this. So t has to be equal to 4. And then we want to find the exact distance of P from O. So if you want to find the distance of P from O, you need to find the position at that instant. So if you're looking for position, you just substitute into the position vector, r equal to 2t to the power 3 over 2 minus 2, and then negative t squared when t equal to 4. So substitute in, if t equal to 4, r is just equal to 2 times by 4 to the power 3 over 2 minus 2, and negative 4 squared. So put in, that will be, so 2 times by 4 to the power 3 over 2 minus 2, that's 14 for the I component, and negative 4 squared, just negative 16. So that means the distance is just equal to the square root of 14 square plus negative 16 square. So put in the calculator, square root of 14 square plus negative 16 square is 2 square root of 113, which is what we want, because they want exact distance, so we don't need to change into decimal, just keep like this. So, and then the units should be meters.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.